Hey guys, welcome back to the shop. So we're going to begin the second phase of the repair work needed for our cable winch system. In the previous video, we have the cable winch drum, and we had to drill and tap a couple of set screws into that, which we got that done, got that completed. So if you haven't seen that, please check out the previous video to see that part of the repair. And then in front of me, we have the shaft and the worm gear that's associated with the same cable winch system. And what we're going to do is this area right here of the shaft is where this worm gear rides. You've got two keyways on here that drive the gear, and the keys actually sheared when it was being used. You've got some high spots on the shaft here from all the torque being pushed against the keys there. We need to clean this up, get it back down to the proper size. And what they had asked me if I could do, because these keys are stretched wide, they're oversized, they asked me about welding them up and recutting them. I suggested a cleaner, more simple solution to that is to just let's machine two new keyways in that and not worry about these other two. That's going to be the cleanest and the quickest solution in my opinion, and help get them back in order. So they are needing this back. Just as soon as the work can be done, they want to get it back together so that they can get their other crew back on the job using these tools here. So that's what we're going to work on today. We'll go to the manual milling machine. We'll set up the indexing spacer and be able to easily index this 180 degrees to get both of our two keyways milled. All right, so let's get started on it. So I got the shaft mounted in the vise here. We're just going to use a mill smooth file and just work the high spots down. You can see the high spots all along this side right here. We've got our keys filed, and now we've got it chucked up in the lathe here. I've got this indicated, and it's less than 1/1000th run out. The center on the shaft, which I need to use in the mill because we're going to be using our spacer and our dividing head, this center has some dings in there where it's been hit, so I just want to clean that center up and then make sure it's running true with this journal right here. So we're going to use the technique where we come in here with our tailstock using a center drill and try to get it just cleaned up. And then what we need to do, I've got a tool in here just so that we can apply a slight amount of pressure in that direction against the drill chuck. And what that'll do is that'll help steady it, because since the center is slightly out of center, it's got a few thousandths run out, we're trying to force the center drill to be in the same position instead of following that hole, and just cut it true. All right, so let's go ahead and knock it out. If I back the center out, you may be able to see that center out of round just a little bit. We'll run our center drill in there till we just start cutting. Like so. If we back out, you can see the high spots there, the shiny. We want to just clean it up. All right, looks like we got it cleaned up now. So what we're going to do is go back in until we just touch. I'm going to go ahead and run our tool in just against the chuck. Run the center in, and then the tool against the center. Just let it sit there for just a few seconds. And we back out, and that center should be on center there, okay? Just giving it a look, and it is cleaned up all the way around. So that's all it took. All right, we'll get it out of here. We'll go start setting it up in the mill. All right, over here on the milling machine, we have our 8-inch Vertex simple spacer here. This is what we're going to use to hold the shaft, tailstock to support the end of it, and then we'll probably end up putting like a machinist jack under it to help support the center of it there as well. This tailstock is on the center line of this. I've already inspected it. We machined this in a previous video and made sure that this was perfectly aligned with the center line, the height of the spacer there. And then what we want to do, I want to make sure that I'm not chucking on this groove right here. I want to be just off of that, but we also want to be 90 degrees to these keys right here as well. And I think that's going to line up pretty good. I'll spin it around here and check it. I don't see it chucked on that groove there. And I think what I'll do, probably get me a machinist square and just see if we can just eyeball square these right here, make sure that they're going to be 90 degrees away from those other keys. All right, we got us a machinist square. We can use this to kind of line up that key right there. But let's go ahead and get our tailstock in there so it'll support it. Back off that, make sure it ain't tight. And we're going to loosen this guy back up. And then we're just going to rotate that just like that. I'm on a section of the keyway that didn't have a lot of damage to it. Now it looks like that's nice and square. Tighten that guy up. Snug up on the center. And then I've got a wrench here to lock it. Okay, that's looking good there. All right, I think we're good to go. Next step is to find the center of the shaft. Here's a little bit better look at what I was talking about here, lining up that key with the square. I know it's probably hard to see on that video, but visually, we're nice and square. Okay, we got a 1/2-inch diameter edge finder. We're going to find the center using the DRO and the half command. And we'll come down here to this journal. All right, that's kicked off. I'm gonna reach up here on the DRO, zero out our Y axis. Gently move it over until it kicks off again. Right there. All right, we measured 2.501. We're going to do half Y, 1.25 inches. All right, and then we take our axis and move it right back over to 0, and that'll be the center of the shaft. Right there. Kicked off. I'm gonna zero out X. Move it down 2 and 15. 2 inch 9/37. Okay, and then that will be the center of our end mill as we plunge down, and then I can just figure out the total distance that we need to move to make this keyway. These measures 2.5 inches long. Going in with a 2 flute, 3/8 diameter end mill. I'm going to get my flat established on the key. So I've got the quill down against the hard spot right there, and then we'll bring the knee up to establish the flat. I just remember one thing I haven't done is support the bottom yet. Let's just go ahead and do that before I start touching off. I forgot to do it and I wanted to, so we'll get a machinist jack underneath here. We're going to put a machinist jack underneath the shaft here to help support it and reduce any kind of vibration that it might have. And since we're on the subject, I wanted to mention this particular machinist jack. This was my dad's. It's always been one of my personal favorite machinist jacks to use. I think it's an excellent design, works really well. This is something that I've always wanted to make for myself here. I've always had intentions to make some. I never have, but this is one of the things that I would like to create in my shop and be able to offer to others out there. So this is something that I'm wanting to develop. Hopefully this year we're going to start working on this. I have a few minor design changes to help improve it, improve the efficiency of it on some of these mills, but I thought I would point that out. So anyway, let's go ahead and get this guy set up. One of the things I do love about this machinist jack, it's got this V anvil there on the top. You can of course make any kind of pad you want if you use this design and just simply stick it on there like that. So it's got a screw there that you can adjust the height, and it's even got a lock nut. That was a brass lock nut that I made years ago because it was missing one. And we'll just run it up until it's finger tight underneath this journal here. See, it's not long enough to come across to this T-slot right here, and I forgot to put a T-nut in there to be able to support it there. That's what I'd rather do. But since it's not long enough and it won't come all the way across here, we'll just point it at an angle and use a strap clamp here to secure it in place. That is 1 inch thick, so we're going to use a 1 inch magnetic block here to support it. I'm about like so. I just like things to kind of look symmetrical when you're setting things up in the machine. And just finger tight. That's all we're gonna do. Because I'll probably, after we do the milling, I need to rotate it. I need to take the tension off of it. So we'll back it down like that. Go back up there to it. Go ahead and lock this down, lock it in place. You certainly don't have to lock it in place, but it does help, keeps it from moving around. All right, there we go. Now we can go ahead and start working on our keyways. Let's go ahead and establish our flat. We're gonna bring the cutter down to a solid stop on the quill here. That's not touching the shaft, by the way. And we're just gonna go ahead and lock that in place, and I'll use the hand crank here on the knee and bring it up to get our flat. Got it running 800 RPM. That should be right around 80 surface feet per minute. I'm bringing it up, and I'm just watching that to create a full circle. All right, that looks like a full circle. I'm gonna go ahead and just run it down by hand. We'll be running a total distance of 2 1/8 to get our full end-to-end length of 2.5 inches. So if you wanna just touch it with your fingernail there, it feels like it's just right on the verge of being there. I'm gonna come up like another thou on the knee. Crank it by hand, and you can feel it. I can feel it now. So that, if you use that technique, it's going to put you within a few thousandths of a measurable size if you want to calculate the total width. I've never felt it really necessary for most of the work that I do. If you just simply get a nice flat established like that and go down half the width of the keyway, it's going to put you right in the ballpark of what you need for just a standard everyday keyway. So that's what we're gonna do. That looks good. I'm gonna bring it back down to our 0 point, and that's where we're gonna make our plunge move. All right, we're gonna get some mist going here. We're gonna be running our Master Fluid Solutions trim mist today. And let's bring it up. We're gonna go up 187 thousandths. Got everything locked. 0. I just crank a little at a time, try to break those chips off. Just be sure if you're plunging like this, you have to use a center cutting end mill. You just go like 5 or 10 thou at a time, just nice and easy. That's 100 thousandths. All right, that's our 187. So what I'm gonna do, I'm just gonna stop that for now so it's not rubbing. And I'm gonna set me a 0 on the knee, because what we'll do when we finish milling this key, we'll lower the knee. We'll go down like, 3 cranks, 300 thousandths, rotate our shaft 180 degrees exactly, and come back up to our 0 point of 300 thousandths, and then cut the second one. So I think we're ready to get going on it. Let's get to cutting. One thing to always remember when you get ready to start a slide or milling something, make sure your feed knob is turned all the way to 0. If you engage that and you're running super fast, you're gonna just mess up right off the bat. Maybe break a cutter, mess up your workpiece. So just try to remember to always have this set to nothing before you start. I'm gonna unlock the table. That one's good. Engage our mist. Now engage the feed. And then slowly come in on it. It's gonna squeak a little at first until it cleans that bottom up. And I just I just look at everything. This looks pretty good. I don't see it beating and banging real hard. It's throwing chips. That's good enough. We've got a short key to mill there. Try to get our miss a little bit better. There we go. The mist works good because it helps blow the chips away and it lubricates the cut. A little bit more pressure there. So we're going to move a total of 2 1/8 in our X direction here. That'll make a total end-to-end length 2.5 inches on our key. Got 1/8 of an inch to go. Stop it a little short and just move it in that last bit by hand. There we go. All right, so what I'm going to do is go ahead. I've got this set to a 0. I'm just going to take it down 300 thousandths for clearance. 1, 2, 3. Now bring it back up to that 0. We'll stop the mill. All right, and now we're going to rotate the shaft. So in order to do that, we need to back off on the tailstock just a little bit. I got to loosen the clamp there. Just take the tension off of it like that. And then I've got our indexing spacer. I've got my 0 at the top on a paint marker. That's my reference. Loosen that, and then we'll rotate it 180 degrees. Let it click in. Not there. I didn't go quite far enough. Just like that. Relock the spacer. Bring the center in until it's snug. Snug up the clamp. And now we're ready to go. So I'm just going to bring it back down to our 0 point. Just keep everything consistent. Just like that. Now let's go ahead and cut it again. Turn our mist back on. There's our circle. It's lined up on 0. So we just plunge it again. So I just take 5 or 10 thousandths watching those chips. I stop it and let them break off so that they fly away. The 100th thou. Ten thousandths. All right, there's our 0, and we are ready to go. 2.110. There's our 2 1/8 right there. Stop everything. And now I need to do a little bit of inspection, a little bit of measuring to see how our key is going to fit. Here's our 3/8 key stock that we're going to be using. I will be cutting a couple of keys and shaping them to fit in there. I just wanted to see how it's going to fit. It's actually fitting in there very nice. See that? Got just a slight amount of interference. So I'm not even going to focus on measuring the width of that key because I've got it right where I want it there. That end mill did a good job cutting that. So I don't see any reason to measure it and have to take any side to side cuts on there to widen it out. I think that key is good right where it's at. I'm going to do a basic depth measurement, just make sure we're 3/16 deep, but I think that's good to go. We'll just use a rule here and just get a visual. And that's definitely where it needs to be, 3/16. Our keyways look good. Everything worked out great. I was going to point out, I was going to show you what we're using for our coolant there. That's the trim mist from Master Fluid Solutions. I've got that mixed up with some water in our tank right there, and then using our Noga Mini Cool to dispense the mist out for a cutter. Cut us a couple of keys. I'm going to use the side of the wheel and the pedestal grinder here to dress the ends. Want to make them round. Let's use a 3/16 radius gauge. That looks good. Cool it off a little bit and do the other side. Looks pretty good. Doesn't have to be perfect. Just trying to get it look uniform there. Yeah, that's good. Come over here to our fine side. Dress the burr off the end of it. All right, there we go. Do that one more time. Okay, we've got our two keys rounded off on the end there. Check them. That fits in there. And I can tell that you can tap it in there. It'll snug up. Let's check the other one. Same. I did use calipers to measure the end, make sure it was 2.5 inches long. And we got it, and I can tell that it's going to snug up as you bump it down in there, which is good. All right, I think we're about done. I just need to get this cleaned up and get it out of the mill. All right, guys, everything is finished up. Our shaft is finished. We got our new keyways milled, turned out good. Our 2 pieces of key stock cut and fit in there. And the shaft does fit inside the worm gear, by the way. I didn't have to do anything to that. And they just want to leave the gear alone and continue running it and just get it all back together. So it's not perfect, but it's going to continue to get the job done. The main culprit was the keys were sheared on this. And then they needed the set screws repaired in the winch drum there, which we have done. So we've got 2 new keyways in the drum. They can get that tightened down on the shaft just like they're supposed to. Got our 2 new keys. They should be able to put this back together and get it back in operation, which is what they're patiently waiting on now. They need to get it together because they said the second crew needs this piece of equipment to do the job that they're working on. I do know that they do a lot of marine construction. I believe they do a lot of pile driving for docks and piers, both for residential and commercial. So it has something to do with one of their winch systems for pile driving. But they'll be happy to hear that this is ready to go. So I need to give them a call, let them know they can come pick it up. I hope you guys enjoyed the video today, and I enjoyed sharing it with you. As always, I try to share some helpful tips on setups and the machining and all the things that we get into when we have to do these repair jobs. So hopefully it's going to help some of you guys out there that are watching for the educational purposes, and if you guys that are just here to enjoy the channel, I hope you enjoyed today's video. And we will see y'all on the next project. All right, see you then.